Welcome to This Explainer. Okay, so think about this for a second. We are living in an era where AI agents are just unbelievably powerful, right? We've got agents that can plan out projects, agents that can retrieve mountains of data, write incredibly complex code, and even reason through some really tricky logic. But here's the massive challenge we're facing right now. What actually happens when you put all of these brilliant digital minds in the exact same room? Well, without a rock-solid way to combine them into a reliable functional system, you don't magically get genius. You just get a room full of people talking over each other. It's chaos. But today, we're going to learn exactly how to fix that. Okay, let's dive into this. Great systems aren't just smart, they're synchronized. Imagine a world-class symphony orchestra. You've got the best violinist on the planet, the absolute greatest cellist, a total master on the timpani. But if they all sit down and just start blasting through their sheet music as fast and loud as humanly possible, what do you get? Well, you get a massive headache. It's just noise. To get a masterpiece out of those brilliant soloists, they desperately need a conductor. Somebody's got to tell them when to start, when to hold back, and exactly how to blend their sounds together. AI systems work exactly the same way. So, here's our roadmap for this explainer. We'll start with the AI orchestra conductor analogy to really lock in the concept. Then, we'll look at why teamwork absolutely needs a leader, compare static versus dynamic execution, and walk through a real-life database debugging scenario. We'll wrap the whole thing up with advanced coordination patterns and some robust error handling strategies. Let's get moving. All right, Section 1, the AI orchestra conductor. Whenever we're designing these complex AI pipelines, we really have to ask ourselves a fundamental question. When you've got dozens of agents acting, who is actually in charge? Who leads? Enter the coordinator agent. Now, strictly speaking, this is the component that orchestrates communication, ordering control between all your agents to produce a single, coherent final answer. What's super cool is that it doesn't necessarily do the heavy research or write the Python code itself. Instead, it strips away all that noise to just simply ask, okay, who should act next, and exactly how do we combine their outputs? It's literally the singular entity responsible for ensuring the timing is right, aligning all the instruments, and producing that final harmony. And what's really interesting about this slide is how we can map this complex AI architecture directly onto very familiar human teamwork roles. Look at this. Your planner agent acts just like your project manager, outlining all the steps. Your retriever agent, that's your dedicated researcher, out there gathering the facts. The tool agent acts as your engineer, building or computing whatever is needed. The reasoning agent is your analyst, making sense of all that raw data. And right there at the bottom, tying it all together, the coordinator is your team leader, your conductor. Seeing it laid out like this really drives home why a conductor is so essential. Think about it. If your researcher hands all their raw data to the engineer before the project manager has even finalized the plan, the whole project just stalls out, right? This brings us right to Section 2. Why teamwork needs a leader. Let's shift our focus just a bit and explore exactly why uncoordinated agents completely fall apart. Why is this team leader role so strictly necessary for success? This stark contrast pretty much tells the whole story. Look over on the left side. Without a coordinator, you've got steps firing off randomly. You get missing dependencies, simply because Agent A had no clue it was supposed to wait for Agent B to finish. You end up with broken pipelines, absolute chaos, and incredibly inconsistent results. Nobody wants that. But flip over to the right side. With a coordinator, you achieve this beautifully clean sequence. You get order, structured flow, and most importantly, a reliable output every single time. The absolute headache of a broken pipeline is entirely preventable if you just have proper orchestration in place. So what exactly is this coordinator doing under the hood to make all that happen? Well, it basically has 5 core responsibilities. Think of it as the ultimate traffic controller of system intelligence. First up, flow control, simply deciding who runs next. Second is data passing, ensuring that the exact outputs from your retriever make it cleanly over to the tool and then straight down to reasoning. Third, dependency management, knowing for a fact that the reasoning agent absolutely cannot start until the tool agent is 100% finished. Fourth is error handling, catching failures, switching up strategies, or retrying steps when things inevitably glitch out. And fifth, final assembly, taking all these disparate, messy pieces of work and combining them into one single coherent answer for the user. Moving right along to Section 3, static versus dynamic execution. Here, we really need to peek under the hood at the mechanics of how the coordinator actually thinks and makes its decisions. So we basically have 2 main approaches here. Static coordination is essentially a fixed flow. It means the system is always going to run all the steps sequentially no matter what. It's super rigid. Dynamic coordination, on the other hand, is adaptive execution based on the actual results as they roll in. If a piece of data is missing, it goes out and fetches it. If it actually finds the answer early, it just skips the unnecessary steps. So, the crucial point is this. True intelligence isn't just mindlessly checking boxes on a list. It's dynamically adapting to the data in real time. It's exactly like a real orchestra conductor, adjusting the tempo right on the fly based on the energy of the room. Let's jump into Section 4, Real-Life Database Debugging. Let's ground this whole theoretical framework by applying it to a highly practical, real-world scenario. Let's actually see this traffic controller in action. Imagine you're a developer, you're debugging an issue, and you type this exact prompt into your multi-agent system. Why is Oracle DB slow? Just this one single query is going to kick off an entire multi-agent pipeline behind the scenes. And this brilliantly illustrates the flow of data from start to finish under the coordinator's watch. Look at how this breaks down. First, the planner takes that massive task and breaks it into manageable chunks. Second, the retriever goes out into the wild and fetches the relevant database logs. Third, the tool agent actually runs specific diagnostics against those logs. Fourth, the reasoning agent comes in and analyzes the results of those diagnostics. And finally, step 5, the coordinator validates the entire process, making absolutely sure no steps were missed and the logic holds up perfectly before finalizing the answer for the user. It is literally a perfectly choreographed dance. All right, Section 5, Advanced Coordination Patterns. Now that we've seen a basic flow, let's pick up the energy a bit and dive into some of the advanced technical configurations you can use to scale these systems for even more complex tasks. There are 4 advanced patterns you really need to know about here. First, we have sequential, which we literally just saw, simple step-by-step execution. Then we have parallel. This one is amazing. The coordinator can actually tell retriever A and retriever B to go fetch completely different data at the exact same time and then beautifully merge their results. Talk about supercharging your speed, right? Third is dynamic, where the coordinator evaluates a result, realizes, hey, this is way too weak, and automatically expands the search on its own. And fourth is the feedback loop. This is where the system checks its own work, finds a flaw, improves the prompt, and then reruns the step. These specific patterns are exactly what make modern multi-agent pipelines so incredibly powerful. And that brings us to our final practical section today, Section 6, Robust Error Handling Strategies. It is time to equip you with an implementation checklist so you can avoid the common traps that trip up so many developers. If you are building one of these systems right now, please take note of this checklist. Seriously, the most common mistakes developers make are having absolutely zero coordination logic, relying on hard-coded flows, and putting in 0 retry mechanisms. To counter this, you absolutely must implement robust retry mechanisms. If an API call randomly fails, your coordinator needs to know to take a breath and try again. You also must build active dependency management logic so your agents actually wait their turn. You should avoid hard-coded static execution flows at all costs. Embrace dynamic adaptation. And finally, ensure your coordinator is programmed to switch strategies automatically if a specific step is just repeatedly failing. Let's just pause and take a breath here for a second. Without coordination, there is noise. With coordination, there is intelligence. This really distills the entire purpose of the coordinator agent into just 2 sentences. You see, it's really not about having the smartest, most advanced individual AI models in the world. It is entirely about how gracefully you can connect them all together. The coordinator is the ultimate system intelligence controller. Sure, it might not do the actual coding or the data fetching itself, but by controlling everything, it turns chaotic, random noise into pure, actionable intelligence. So I want to leave you with this provocative question today. How will you orchestrate your own AI systems to achieve intelligence instead of just generating noise? Are you going to let your agents just play randomly, or will you step up to the podium and become the exact conductor they desperately need? I really hope this explainer has given you the structural blueprints to go out there and build some beautifully synchronized, highly dynamic systems. Thank you so much for joining me today, and hey, happy building!